1, this was the first question. It said to round to the nearest tenth. So not a lot of mistakes on your part made here, but there was a couple that did not round to the nearest tenth, and that would stink, like to lose a couple of points off of something silly like that. You know what you're doing. You just didn't follow directions, so be careful. For these, I gave you one angle on the side. So you can use 90 minus that angle to find the first angle. That was the 15.5. And then you've got to set up your trig functions. And I always recommend to go back to what the original information that they gave you was. So I gave you angle A and I gave you side B. So if I wanted to find side A, for example, I used the 74 and the 29.2. And I would say that tangent, which is what this setup is, tangent of 74.5 is A over 29. The value's in the bottom, so we multiply it out this time. 29.2 times the tangent of 74 should be 105.3. Again, make sure you're rounding right. Then to find the third side, you can do two things. Pythagorean theorem, but you just use it around a rounded value and possibly the wrong value. So the safer bet is to stick to the information they normally gave you, but this time you're finding you're finding side C. So in respect to the 74.5 I gave you, 29.2 is adjacent to A, and C is the hypotenuse, and that's why it's now cosine. Cosine of 74.5 equals 29.2 over C. The value's in the top this time, so we divide. We divide the top by the angle. So it would be 29.2 divided by the cosine of 74.5, and you get C. If and only if you have the extra time. So I would say, like, if you get through this, you go on to the non-calc portion, and you have time at the end, and you say, Miss Christweiser, I want to go back to my calculator part, and I'm going to take from you the non-calc, which you won't get back, then I would say go back and check that using the Pythagorean theorem. Only then, okay, if you've made sure you made it all the way through. All right, the second one is an example if you got two sides, no angles. So I know the right angle, but I don't know either of the acute ones. So the first thing I'm going to do, which is on the bottom here, find that missing side using the Pythagorean theorem. And that missing side is 46.8. But then I toss that information aside. Don't use it because that's a rounded value. I want to stick to the information they originally gave me. If I'm looking for angle A, for example, the 76.5 is opposite. The 89.7 is the hypotenuse, and opposite hypotenuse is sine. So I say the sine of A equals the opposite side over the hypotenuse. And then because I'm looking for the angle, I hit those -1 buttons. Sine -1 of 76.5 over 89.7, and I get angle A is 58.5. Then you have two choices. Subtract it from 90, and if I'm running low on time or I feel like I'm taking too long, I'm certainly going to do it that way. The other option would be able to set up your trig function using B and the two sides you're given. So 76.5 is adjacent to B and 89.7 is hypotenuse. So I could have also said the cosine of B equals 76.5 over 89.7. And then I could do cosine -1 of 76.5 over 89.7. And I get angle B is 31.47, which is 31.5. So both ways got you the same answer. The subtracting from 90 is obviously faster. Yeah. Okay, then came the straight up calculator portion. And to me, these can be the easiest or these can be the most difficult if you don't know what you're doing. These require the least amount of work, and they should be the easiest, but this is also where you'll probably get no partial credit. It's an all or nothing situation. So the first thing I would recommend is if you have a prayer partial credit, it's because you showed step 1. You have to at least give me what you're typing in your calculator. So because it's secant, I want to do straight up. This is not one where I have to figure out a reference angle. This is literally just typing into the calculator. Secant is the reciprocal of cosine, so I do 1 over the cosine of that angle. 1 over cosine 131.67 is -1.504. The question came up, is it okay for this to be negative? Absolutely. And if you think about it, you're trying to find the cosine of 131.67, and that's in your second quadrant. And in your second quadrant, cosine would be negative. So that actually makes perfect sense. Don't be alarmed by a negative there. Then tan of 31 degrees, 45 minutes and 30 seconds. You can either convert and then type in, or you can literally type that in the calculator as it is here. tan 31 degrees, 45 minutes and 30 seconds, and you should get 0.619.
We got the calculator for this.
This is definitely calculator. Everything that's on this class kick is calculator. And then cosecant would be 1 over sine of that angle, and you do negative 1.1, you get negative 1.167. And again, if it's negative, it's going this direction. 121 would be in between negative 90 and negative 180. So it makes sense that all students at calculus, that sign would be negative there. Those should be your like freebies on the test. You just got to know what you're doing. Then you come to the inverse ones, and this is where it gets a little bit trickier. So let's say I do cosine, I'm going to do 6 first. Cosine of theta equals negative 0.67456. First of all, when I'm looking for the angle, I know they are different. When I'm looking for the angle, first, if it's negative, I'm changing it to positive. Second, find the reference angle by using the -1 buttons. Sine, cosine, tan. -1, -1, -1s. 3, figure out your quadrant. Based on all students take calculus. 4, find the actual angles. Using the rules, if it's in the first quadrant, we keep it. If it's in the second quadrant, we do 180 minus what you got as a reference angle. Third quadrant, 180 plus theta prime, what you got for your reference angle. And third quadrant, 360 minus theta prime. So for 6, I'm doing actually first cosine -1 of 0.67456. Second, cosine 0.67456. And I get my reference angle is 47.6. But that's in the first quadrant, and my original question is negative. Cosine is not negative in the first quadrant, so I can't even keep that as one of my answers. I move into the other. Good morning. I move into quadrant 2 because cosine would be negative there, and quadrant 3 because cosine would be negative there. So in quadrant 2, I do 180 minus 47.6. And I get one of my answers is 132.4. And then in the third quadrant, I do 180 plus 47.6. And I get 227.6. And if you have the extra time, we check it by doing the cosine of each of those and seeing that it matches my question. Those are quick and easy to check. Go to tangent. So now tangent of theta is 1.575. So I do second tan, 1.575. And I get theta prime is 57.6. Tangent is positive in the first quadrant, so that is one of my answers. It is also positive in the third quadrant where I have to do that plus 180. So 57.6 plus 180 gives me my second angle, 27.6. Number 8 is cotangent. So this is where there's two things that are different. First of all, in order to actually find the value, I don't do 1 over tan -1. The -1s never go in the denominator. I do tan -1 of 1 over, and I make this positive, 1.8293. So the tan -1 never goes in the bottom. And I get my reference angle is 28.7. That's in the first quadrant. Tangent, which is the reciprocal of cotangent, is not negative in the first quadrant. So I don't use it. I find it in the second and the fourth. All right, so since we know that tangent is positive in the second and the fourth quadrant, negative in the second and the fourth quadrant. For the second, we're going to do 180 minus that 28.7. And in the fourth quadrant, we're going to do 360 minus the 28.7. And we get 151.5 0.3. And we get 331.3. Oh, and actually this said to round to 3 decimal places. So those examples, they should have been 3. So this should be, oh, no. Because I should have gotten the 3 from here. Make sure you pay attention. Not like what I just did. Make sure you pay attention and get those 3 decimal places. All right, go to, let's see, that was 8. So go to 9. Now you're dealing with secant. So we're going to do cosine -1 of 1 over 1.7932. And I get theta prime is 56.106. That's your reference angle. And because it's positive and cosine is positive in the first quadrant and the fourth quadrant, we get to keep this as an actual answer. And then in the fourth quadrant, we do 360 minus that. 303.849. And that's the second one. And then this last one, if you catch it, it says sine is bigger than 1. Sine can't be bigger than 1, so it would be no solution. If you did sine -1 of 1.5, you would get an error on your calculator, so it would be telling you that there's no solution. Okay, that is just the calculator questions from your test, so you need to make sure you also complete the review to get all the other non-calculator questions. All right, this was the extra review that was assigned on Friday. If you want to start to keep in mind anything that's 30, 60, 90, 45, 45, 90 related, like that 34, 36, 38, this would be on the non-calculator portion, anything that you can use your special right triangles for. Again, non-calculator portion. And then the stuff that the SOHCAHTOA stuff for triangles, that would be on the calculator portion. So any questions from these first? Let's start here. Yeah.
How would you solve 34, 36, and 38?
Okay, can we pick one? 34. Okay. So 34. Should have just opened it blank. Has both special right triangles in it. This is A, D, 24, C, B. Okay. Has both special right triangles in it. You want to start with the one that obviously gives you a length. So on the left-hand side, that triangle is the only one that actually gives you a physical length on a side. So when you look at your 30, 60, 90 triangle on the left, it already gave you A. So if you want to use a different variable, you totally can. But opposite the 30 is just the variable. Good morning. Opposite the 60 is, thank you. Opposite the 60 is that variable times the square root of 3. And then opposite the 90 is the 2 times the variable. And again, usually we use A, but because A is already on there, I don't want to confuse you. So we just switch the variable. Then of those 3 sides, you're going to get given 1. In this case, we're given this side. We're given the 2x. So if 2x equals 24, and I divide by 2, then x is 12. Which means the side length that has B on it is 12. No, sorry. The side that has A on it on the bottom would be 12. And then the side length that has B would be 12 root 3. So if I was only to complete that triangle, that would be done. They're going to give you one side length. You set it equal to whichever value you have there. And then you'd solve for the variable and then figure out from the other sides what you're missing. Yep. Yes, so these will be kept exact. You won't have a calculator for these kinds of questions. So you'll leave it exactly like that. But then you got to complete the triangle on the right now. The triangle on the right is a 45, 45, 90 triangle. So the side lengths that are opposite the 45s are normally your A's, right? So this could be A, this would be A, this would be A root 2. Opposite the 90s, A root 2. So the 12 root 3 that's on the B side would also be here because it's an isosceles triangle. Opposite the 45s are going to be the same. And then opposite the C would be 12 root 3 times root 2, which is 12 root 6.
And how do you know it's an isosceles?
Because it's 45, 45, 90. So both those angles are the same.
Sorry, I thought you were talking about
No. Yeah, no. They're two separate ones. you can't use the big triangle because you have a 60-degree angle, but a 60, 45, and then the one at the top would not be 90. So you can't use those special triangles with that one. Yeah.
You have it A equals 24 on the answers, but doesn't it equal 12?
The A on the bottom? Oh, yeah, no, it's 100% 12.
Yeah.
Yeah.
24.
Nope. Okay. Thank you. So then B is 12 root 3. Oh, so the whole thing is off. Wow, that's fun. Okay, then that one's 12. Hang on. So then D is 12 root 3. C is 12 root 6. Thank you. I will update that whole thing. That's the correct answer. Okay, how about 56. Now we switched to our reference angles. So this goes back to finding where it's located. Sometimes you have to do a coterminal, like 60 and 62. You had to do a coterminal. Well, you don't have to, but it's way easier to do a coterminal. Figure out where it's located, figure out what your reference angle is, and then use the all students take calculus to figure out your positive and negative sign. So 58 would have been fourth quadrant, which means sine and tangent are negative, and then cosine would be positive, and then the reciprocal functions take on the same sign. 60 goes all the way around your circle one time, and then it goes to 45. Or the coterminal angle is 45, so first quadrant. 62, coterminal, add 360, you get negative 150. You can add 360 again if you want a positive coterminal, and that's 210. Third quadrant. Reference angle would be 30. Set up your triangle. And you get those 6 trig functions. Questions on any of those? So non-calculator part. 64 and 66 are pretty similar. It's just that it's only asking for one of them. Then we switch to calculator part. So calculator, when you get to 74, 78, and 80. And this says Friday's part, but they're both on Thursday. But it's on the calc part. Everybody's good on those? Yeah? Okay. Okay, correction here on 36. When finding, you would first start with this right triangle. 7 is your x root 3, so you would divide both sides to get x is 7 root 3 over 3. So this one is correct. 2 times that is 14 root 3 over 3. That is also correct. And then because it's a 45, 45, 90 triangle, this one is also 14 root 3 over 3. What is wrong is this here. Opposite your right angle should be a root 3. So it should be 14 root 3 over 3 times root 2, not times 2. And that should give you 14 root 6 over 3. So the correct answer for Q on that one should be 14 root 6 over 3. Now the inverse ones. So this is where you're given the sine, the cosine, and the tangent, or the sine and the secant in this case, and you're looking for the original angle. So we use the -1 buttons. And then you have to figure out where it's positive or negative based on what it's given and use your reference angles. That would be calculator part. Yeah, sorry. $94, $96, and $98 would be back to non-calculator part. This is where you're setting up your triangle. You're figuring out which angle it is, and then you're figuring out which quadrant or quadrants, like it normally is, it lies in based on all students take calculus. Okay, then solving right triangles. This is your SOHCAHTOA. So you'll set it up. This one says C is the right angle. And then it says solve each, which means find all the missing sides and all the missing parts. Questions on those? All right, I'm going to let you jump into the class kick where we do the calculator ones, but this is your full review. This is obviously 5-1, 5-2, 5-3, and 5-4. While you're working on the class kick, I'm going to give you back your quizzes. That's the 5-1 and 5-2 part, okay? And then obviously we just finished 5-3 and 5-4 last week. But on the review, I highlighted in yellow the ones that would be the calculator parts. It actually says part 2 here, but we are going to start with the calculator part. I don't know that matters, but if you need to mentally prepare yourself, you're going to start with the calculator part, because that gives you the opportunity to, if you do the calculator part, you switch to the non-calculator part, and you have time to go back to the calculator part, we will allow it. We will collect the non-calculator part. You can't go back, forth, but you can go back to the original if you've got the time, or to the calculator part if you've got the time. So for questions like 2 and 3, they won't be just convert. They would be like find the tangent, sine, or cosine, one of those. So you do need to use that button in the calculator, but it won't be like a straight up conversion. So these would be, why is that not highlighted? That one would be calculator part. Four, obviously, is finding your coterminal. 7, finding the 6 trig functions given the endpoint of the coordinate. 9, 11 is kind of like 7, but you have to draw it out first. 16, 17, it says just find the 6 trig functions so you can set up your triangle if you want. You can use your identities too there. 21 would be the 6 trig functions, and it's kept exact. So this is without a calculator. You're not using SOHCAHTOA to find the missing side. You're using the Pythagorean theorem, or in that case, a triple, and then you're finding them all. There's a question here at the top. Don't forget about that. That's your Pythagorean identity. So this is your sine squared plus cosine squared, or 1 plus tangent squared, or cotangent squared plus 1. This is still non-calculator for 25, 26, 27. Then we get to the calculator part for finding the sine, the cosine, the tangent, that kind of stuff. Back to 32, not calculator. 34, 35, calculator. 39 and 40, calculator. That's SOHCAHTOA. And then here's some just extra ones on 7 where you get your special triangles. This is your non-calculator part. So I feel like every year on the non-calculator part, somebody comes out, raise their hand, and they're like, aren't we supposed to be able to have our calculator do this using SOHCAHTOA? If it is a 45, 45, 90 triangle or 30, 60 triangle, the answer is no. You have to do it without. And then obviously there at the end, there's your calculator brought back in again. Lauren?
Are we getting back from the sheet or no?
We're actually going to meet today, and I'll let you know exactly what you're getting.
Okay.
Yep. Yeah.
Can you say again the triangle part we won't get calculated for?
Say again, what kind of, like a 30, 60, 90 triangle or 45, 45, 90 triangle, you will not have a calculator for.
Only the first problem we did.
Yep. And then the angles that are reference angles, no calculator. The triangles that you set up using coordinate points, no calculator.